Welcome members, today we are going to see how we differentiate sin squared x from first principles. So we are going to try these two as your exercise. Then the unit we are going to use today is in radians. It has this small angle approximately 0 tends to 0. Sine of this is this, cos of this is 1. Then also the factor formula for sine. So to specify number 1, I said let y be sin squared x and delta x delta y be small changes in x and y respectively. Meaning that from my y, if I see a small change in y, it means that even in x, I'm going to be having sin squared x plus delta x. Allow me to take y the other side. I'll be having now my delta y equal to sin squared x plus delta x, now minus, when I take y the other side, I have it like that. So, now minus sin y is sin squared x. And from here, you say difference of the squares. So, I say now this will be delta y equal to difference of the squares in the brackets now, sin x plus delta x plus sin x. We add, then we subtract. So from there, I have applied the difference of two squares. This is the square, this is the square, then subtracted. And from here now, we subtract factor formula in this order. So now my delta y will be, if I'm part of this one, I'm going to be creating the big bracket first. So you see, if we add in, this is how we do it. So you say 2, then sine of, I add these angles, this thing I'll be adding this angle plus this I'll be adding 2x plus delta x over 2. Then we subtract them, I'll be adding now cos of, when I get this minus this, I'll be adding on delta x, then I divide by 2. Brackets here, the same, but this time I'm going to handle, it's going to be 2, then sine, we subtract these angles, I'll be adding, subtract this from this, so see that x will go, and then delta x over 2. Then I add them, I'll be adding now cos of this plus this, 2x plus delta x over 2, then in big brackets. From there, let us simplify and see. So I have my delta y equaling to these 2 and these 2. They are going, because I'm multiplying out, so these 2 and these 2 give me a 4. Then sine in brackets, this divided here, x plus delta x over 2. Then cos of delta x over 2. Then times this, which is sine delta x over 2. Then times cos, this divided by this to get x. Then this divided by this to get delta x over 2. So now members, I apply this that in radians, as x delta x is something so small, it means that cos of a small angle by 2 will approximate a 1, and sine of a small angle, sine of a small angle will approximate that small angle from here. Now allow me to substitute. I'll be adding now delta y equaling to 4 sine. Then this, all of this is going to be a 1. So there, allow me to set times. Now 1 times. This one is going to be delta x over 2. Then times this cos. So you see by this one, by this is going to be 2. So after there, I'll be adding now delta y equaling to 2 sin x plus delta x over 2 times, allow me to start with this, cos x plus delta x over 2, then times this delta x. So I divide by delta x, then by the side delta x. So my delta x will be 2 then I said, as delta x tends to 0, it means that now in delta x means that when I substitute the where there's delta x, I substitute 0, means that the whole of this will be approximately that. So now, from here, by the y dx is going to be 2 sin x. This is sin x plus, now this is 0 over 2, then cos of x plus 0 over 2. But my y was 1. So dx of sin squared x becomes 2 sin x cos x. So members, that's how we do this. So try out this. I wish you the best.